Hi and welcome everyone to this episode of Breakpoint. The topic for today is DevOpsification of threat detection development. The guest for today is Wasim Halani. He is the Director for Detection Engineering at Securonix.
To boil the ocean and try to detect every threat or every PTP within the MITRE framework. With the idea of detection engineering, what you're trying to do is you're trying to merge detection development with your traditional software development practices and DevOps practices.
Yeah, we'll have to add that in the description for the listeners to follow.
At one rule which has triggered, which is very high fidelity in one customer, we have seen that same rule be very noisy in another customer. Not every vendor gives equal amount of logs.
Welcome to Breakpoint Security Podcast, folks. Join us as we explore the fascinating world of smart security teams and their cutting-edge security and engineering practices. We'll share fun and engaging stories about clever optimization techniques that scale your defenses and also keep your data safe. Tune in and be a part of the conversation where exciting innovation meets real-world application in cybersecurity. Welcome to Breakpoint, Wasim.
Thank you very much, Neelu. Thanks for having me on this podcast.
So, just for our guests, detection engineering has been quite a topic for a while. Although we know that threat detection has been there for a few years now, but the growth has been largely linear. We started with having firewalls, network traffic analysis, and endpoint detection, and a ton of other products after that in the last few years. And we are at a place where we can do a good bit of correlation with products like SIEM and other products that we have. Now, when you think of why we are talking about detection engineering, you will know that there are a lot of rules that come with all of these different kind of detection products. And writing rules can have its own set of overheads, right? You have to do a lot of analysis. It takes a lot of time to understand each and every threat and how it actually represents itself in your environment. And then there are a lot of these attacks that keep happening these days. There are 0 days that happen where we are still figuring out there is no patch available. There are different kind of attacks that happen, and hence the frequency of these necessitates that we have something that automates the hell out of the detection the detection rules that we are writing. In all of this, I think this is an attempt to also leverage engineering and see what we can do about writing detection rules. And we'll know much more today in this episode as we dive deep along with Wasim as to where all it can go and what are the possibilities. Wasim, what do you think? What are the problems other than just the frequency of these attacks and the scale that we need as of today for threat detection? Where the traditional SOC teams are faced with these challenges of building threat detection for their specific environments.
Yeah, so like you rightly said, right, threat detection is evolving as an industry, both from the threat actors perspective as well as also from the defenders perspective, right? Threat actors are moving fast, and unfortunately, the traditional mechanism or traditional methodology of building detections was more ad hoc in nature, more manual, and it used to be tracked in, you could say, Excel sheets, in different environments, in different teams. It doesn't scale at a level that we want today because it needs to be fast paced. And unless you're fast paced, you will not be able to catch up on the new threats that come in. And you will start with a process that you cannot grow out of, right? You're stuck in that kind of a cyclic disorder where you're stuck with X number of policies or an X number of detections, and you're not able to scale and grow towards the more refined detections that you want to be doing to catch up with the threats that are coming for your organization. So detection engineering is that evolution of the traditional mechanism or traditional methodology that we had for building content. Not only within the SOC, it could be in any platform as well, any product. Everywhere this is a concept that is being adopted today, wherein you use engineering principles to solve the older problems that we used to have with traditional development mechanism.
Yeah. So with respect to threat detection, right, there are a few things that we understand that can be difficult. Like I was saying, you have to do a lot of analysis, you have to understand the environment. But in technical terms, can you elaborate a little bit more why detection is so difficult? Like why are we, so before we actually jump into engineering, why is it so difficult? What are the technical aspects that a team has to look into in this case?
Right. See, in an ideal world, we would all love to detect every possible known threats and even possibly unknown threats
None
that
of the
for an organization, right?
yeah.
Unfortunately, we don't live in an ideal world. So things are having a lot of variety and variability in the system. Now, when organizations decide that they want to be able to detect threats, if I go across every possible thread, I will not be able to scale myself in terms of detecting those actors. Whereas if you look at MITRE framework, or if you look at any threat report, you realize one very important critical aspect is that threats are many threats, in fact, not all in general, but many threats are very geo-specific or industry specific. There are some threat actors who only work against banking sector of fintech. There are some threat actors who only work against oil and gas verticals. There are some threat actors who work against healthcare industries. So when you are focusing on threat detection, right, you need to be very aligned to what exactly is the threat perception for your organization. You cannot keep going to boil the ocean and try to detect every threat or every TTP within the MITRE framework. And there is the other reason for this, why it becomes more and more difficult and you cannot boil the ocean, is because of cost. Businesses and within a business function, cybersecurity is always, or majority of the times, a cost function, right? It's not a revenue generator. So businesses
Yeah.
have to optimize their environment to make sure that they're using the resources available to them in the best efficient manner. And if I start trying to detect every threat possible, the cost goes significantly up. That includes cost in terms of people, right? The more detections I have, the more alerts I generate, there are more people I need to monitor that. Secondly, the cost of the platform that I'm using, right? Because the more I want to detect, I have to ingest more logs for that ecosystem. And effectively, I need to pay more for my SIM platform, or maybe for my, if my coverage has to be increased, my ADR ecosystem. So there is a very direct correlation with the cost over there. Right. And then the corresponding outcome of this is that if I have too many detections, then I effectively have too many alerts, and that triggers the infamous what we call in the thing, threat monitoring industry, is the alert fatigue. And not only in SIM
Yeah.
platforms, this happens across everything: EDR, XDR, you have cloud, everywhere you have this alert fatigue where you get too many alerts bombarded from everywhere, and then you don't know what to focus on, right? You might have strategies, and that's where organizations have to get mature enough to see that, okay, what do I want to detect? How will I process the detections? And are the detections actually making sense for my organization and my team? So there should be an element of threat intel that provides a guidance to organization. There should be an element of risk that provides guidance to an organization that, yes, this is what I want to be focusing and monitoring and putting my resources to. When you start into threat, you could say detection engineering or threat detection, the maturity as you go along the process will define all of these requirements for your organization, and it makes it more refined, more efficient for you as a entity to start moving in that direction. Okay, these are the bare minimum threats I want to be detecting, or these are the bare minimum TTPs I want to be detecting in the MITRE framework. And the reason is because these are the threat actors that are more focused to my industry, and my threat intel says the same, my business says the same. So now I have a very focused element. I don't have to go boil the ocean anymore then.
So they can basically prioritize it that way.
That's a prioritization. Unfortunately, while it's easy to say it on the podcast, it is not an easy problem. These data points are not very easily available always, right? You need to invest in threat intel, you need to invest in your vendors, you need to invest in your program, in your people, in your technology. Again, it goes back to the cost. The budget's not necessarily always available. So the business has to rationalize where do we invest all of these. And when you put investment in one technology, but not the people, then that technology fails. So again, threat detection becomes difficult. So it's a cat and mouse game. It's like a cyclic wheel of issues that we keep having. And it basically piles up to the problems that any organization faces. The maturity of
Yeah.
the organization will define, okay, this is how I want to be doing it. If you have good business support, your management supports you well, That's when you have seen organizations succeed in this building this entire program.
Yeah, yeah. I think there'll be a lot of factors. We have had some of the episodes earlier, especially one that we had with Shweta, where we were talking about leveraging the MITRE framework for the traditional way of doing threat intelligence and how efficiently you can do that. But even there, prioritization meant and I think she was telling us, and as we know, there are, like you are saying, there are a lot of other factors that will come into play.
Yes.
But before we go deep into that, there's a more interesting aspect of detection engineering, which is the DevOpsification part, which I think which is what I am truly excited about, having seen Agile and Agile development and the potential of Agile
Mhm.
and DevOps. It becomes quite interesting to see where that can take threat detection too. So what I wanted to know was how to specifically, which are there any specific DevOps principles that play a role here that we adopt, or we totally adopt the DevOps way of working or engineering, as we say, in case of detection engineering?
Right. So, if you look at any SOC team, right, you would normally have a structure of people who are analysts, and then you have content engineers or any cybersecurity function, right? Programming or engineering is not a very strong forte for the older traditional, I could say,
Oh yes.
cybersecurity analysts, right? When I started my career, it was not a big forte. I could do smaller scripts and stuff like that, but it was never a requirement to jump into this field of, could say, ethical hacking, BAPT, and all. It did boost you up. It did provide you the extra benefit, and there are a lot of security engineers who do well in coding and all. But what happened is traditionally, because of this absence of engineering mindset, because of the absence of this knowledge of software development, the cybersecurity function started evolving in a much more traditional manner. You used to have all of this content maintained in Excel sheets, like I mentioned. It was all manual as a process. With the idea of detection engineering, what you're trying to do is you're trying to merge detection development with your traditional software development practices and DevOps practices, so that now you're not only taking, you're not focusing on only just one element of cybersecurity. You're taking the best parts of both the worlds. You're using software engineering principles, and then you're combining it with threat detection. And then that's what we have, something that a colleague of mine coined as detection development lifecycle. Like how we have software development lifecycle, you now have something called as detection development lifecycle. Essentially, you start with the same logic that you do with software. You plan it out, then you kind of like build a prototype, and then you try and test it out and see if it works. And then you go and evolve, have quality assurance, you have testing, and then you have automated deployments, continuous deployments, versioning. So all of these aspects that we have in traditional, and that has kind of like helped software development teams grow faster, especially with DevOps. You bring all of
Yes.
those best parts into your threat detection program as well. That's where you marry the two with detection. That's why you have the engineering aspect mentioned over here. So this is going beyond where cybersecurity teams, especially SOC teams, have not ventured much into. You used to have small automation teams within a SOC usually, right? Who would help with kind of like building these toolings. But usually now what you see is that people who get hired are or in the cybersecurity domain, they are asked to have some level of scripting knowledge, that some level of engineering background and knowledge that will help them adopt all of these concepts much more faster, right? So that's how these DevOps principles come into the picture. And one very important element of this entire story with DevOpsification or detection is, you have heard of this infrastructure as code concept, right? This is
Yeah,
something
yeah.
DevOps teams use a lot. They have a very large cloud environment, but the way they maintain it and the way they do deployments is with a small YAML file, right?
Yeah.
They don't have to go and manually click and click each button to deploy things. They
Everywhere.
simply
Yeah.
have it in a CI/CD workflow. They have a YAML file which they write the entire configuration, and they can simply go and launch an entire ecosystem of, you could say, cloud infrastructure just with simple YAMLs. Same logic gets applied over here. You define your threat detection, you define your use cases, everything in a human readable structure. It could be YAML, it could be XML, it could be JSON, it could be something else, right? And you effectively use that to start tracking your entire life cycle of what we mentioned as detection, DDLC, and use DevOps principle over there to do code versioning, whatnot, right? Sigma is a open source framework, or you could say project, that kind of like popularized this entire concept. They use YAML. There are other vendors who, like I said, use XML, JSON, some use Python, some use even something called Stormil. So there are anything is possible over there. You can define anything in your own construct for your platform or for your ecosystem. The end game is that you have it in a human readable format and a codified format. So you can use that in a automation that you would want to build later on.
Yeah, in fact, on a hindsight, when I first got to know about detection engineering, it was like, okay, why have we been limiting? I just saw the pattern that in security, we've been limiting ourselves a lot to script writing, right? I mean,
Mhm.
why have we not already utilized the power of engineering, like true engineering, in the
Right.
sense of starting from versioning to everything, to making sure that you have configuration as code anywhere and everywhere where you can replicate,
As
create,
cybersecurity
and
professionals learn about this entire DevOps and software engineering principle, that's how you get the evolution from DevOps to DevSecOps now. Have you could say even AppSec, you have kind of like evolved a lot with the automation. AppSec and traditional VAPT has evolved a lot over there in those terms, but the
yeah.
other aspects of cybersecurity, not much, right? You have now many vendors and teams who can automate a lot of these elements with cloud because cloud is much more flexible in terms of APIs and all. So you have those capabilities over there. But I'm very much optimistic that as the idea grows, there will be many security engineers who start adopting software as a foundation to their own skill sets rather than keeping it something as complementary to their skills.
Yeah, yeah, exactly. Okay, so now let's get into the meat of the topic, which is on how we do it, right? So it's one thing to say to do true engineering for detection that we are talking about. It's another thing to bring it about to life, build all those systems, have the prerequisites in place, understand your environment and context. And this is me saying as an outsider who's not doing it on a daily basis, you would know better. What would you suggest is like the groundwork that's required towards such a journey, and how do we like really start from day zero, if I was to put it that way?
Yeah. A great question because, like I pointed earlier, the foundational requirement of this entire thing with detection engineering, while you do need your cybersecurity skill set, that's nobody's discounting that, right? You need to understand how operating system works, how does it break, how your network security works, how you do you reverse engineer malware, how all of those elements work. But to translate that into threat detection in a much more agile manner and much more efficient manner, you need to start having an engineering mindset, right? And this is more focused on software engineering mindset. You need to understand the concepts that get applied over there. So this is something, if your team does not have the background in software development, then you can kind of like train them initially, but that needs to be, you could say, explained to the team that why are we starting on this journey? Because if they don't understand, they will feel, what am I doing software engineering? I had signed up for cybersecurity over here.
Yeah.
And this is a challenge we faced also, right? People did not quite align to the principles that, okay, we need to grow faster and we need to build content in a much more, let's say, agile manner, in a much more reliable manner, rather than just simply building content and shipping it out. So that does not work for software. That will not work for us, right? So those elements have to be captured. So engineering mindset is a primary requirement when you are starting this kind of a program, right? And what you also need to understand that every detection is effectively a development of a life cycle that we're doing. You start with one idea at the start, and then once that idea goes through the entire life cycle, it will also get sunset. Every product has its end life, right? So it cannot be that I build a detection and I will never look back at it. It's a continuous iteration, like how we have in Agile. You build small pieces of it, you improve on it, and then you go forward. So you have, suppose, a new threat or an emerging threat that's coming up, right? Something that goes very wide in the community, that there's a new zero day, like you mentioned, and there needs to be the community is very fast, right? The threat detection community, like if you are on Twitter, if you're active on Twitter, you'll see this. People are shipping out new detections, new TTPs, new information about these threats very quickly. Sigma has contributed a lot to that in terms of the awareness for the folks. So the community moves fast, but taking that idea and translating into a detection in your ecosystem is
Yeah.
the challenge that we need to solve, right? So you have the prototype available in the field, but then from there on, you need to package it as per your requirement. You need to make sure that you are able to test it out. Software engineers do not release code without testing, right? And that's the most important element. If you release code or if you test in production, that's the big no-no. Or you have lots of memes online also regarding that. So you
Yeah.
don't do those testing in production. You don't release directly to production. You have the prototype, you build on top of it, you test it out, you validate, and then you start packaging it. That packaging involves multiple steps. You have quality assurance within that packaging, you have versioning, you have end-to-end testing, you have false positive tuning. All of these are unique elements for detection engineering. They are not for your, or you could say they are, could say a merger between detection and software at that point. False positive reduction is very important, right? It's not an easy problem to solve because when you're deploying it, talking from a vendor perspective, when we build it out, essentially, it gets challenging because every environment is different. All of our customers
Yeah.
that we provide content for are different. So it becomes challenging to say that, okay, this one false positive that I've reduced or removed from my detection will work for all. It'll work in terms of reducing that specific, but there'll be other elements or other types of
Like
events or other
different
activities
types
that
of,
happen.
correct.
Exactly. So that becomes a bit tricky. Nonetheless, you kind of like go through the life cycle and you kind of build a prototype detection. You have a version one of your detection. You deploy it out using some sort of an automation. You cannot, at this phase, when you're building out a program, do it manually, right? And this is the problem we used to have initially when I started at my current organization. We had manual deployments for customers, and that did not scale at all, right? Because then you are effectively using that same engineer to build, to test, and then to also deploy. And
Yeah.
it kind of like we are effectively getting 1/3 of the resource time available for development work. So what we decided that this journey of DevOpsification was effectively that, right? We understood that software engineers are able to do this much faster, so why not us? We focus the engineers' time on the development of detections. The quality assurance, the testing is automated, the deployment and all of those elements are automated. Then the last phase is your monitoring phase, and that monitoring is also then kind of like automated. The analysis from the monitoring is then taken back by the engineer to optimize their own detections. So effectively, for the 4 or 5 stages that we have, you try to bring some level of automations, same way that software teams have done. They have offloaded this entire function to DevOps and automations to kind of like monitor, generate alerts for them. They take those feedback and come back to the core meat of their function, right? Previously, all of their time was getting split up into multiple activities. So we built when we started on this journey, we did not have any kind of like a validation tool or any sort of like testing tools and all. Over the past years, we have tried to fix this, and this has been our journey, right? I wouldn't say that we have achieved our end goal, but we have come a long way in terms of where we are with our own journey for this DevOpsification that we call it, of our detection engineering program. And we have achieved a lot. We kind of like built internal tools to automate the configuration validation, the same way that you have for Docker containers and Kubernetes. We have our own code language now, and we kind of like have an automation tool to validate those configuration. We have an automation tool that does end-to-end validation of the entire detection, meaning you have your data coming in, you parse it out, you normalize the logs, and then you effectively test out the detection using the known bad events. It should trigger a violation, or it should trigger an alert in your system, and then we can monitor that at the end. The last element, which is, like I said, very tricky, is the false positive. That happens more dynamically. We do know some known false positives. We whitelist those entries into the detection, but then it's like an iterative. That's where the monitoring phase helps us. The monitoring
Yeah.
allows us to take the feedback loop back to the engineer. They review the details of why exactly it's triggering so many false positive violations, and then we come back to a new update of the detection.
So before we move further, there were a few things which more on the practical side of agile development, and from my experience, generally we have. So suppose you're starting from zero, like we were talking about. We have these things in place. We have an idea of what we want to do roughly. What? How do you define your MVP? Like you may not be using the same concepts there, but what is the, is it a bunch of detection rules that we start off with first? What does it logically make sense to define first in terms of detection?
Yeah. So my experience is slightly different here because I come from a vendor background. But when we talk about a generic enterprise, right? Every enterprise has their own vendors, and every vendor provides more or less some sort of an out-of-the-box detection. You don't go and enable everything under the box because that
Correct.
will unnecessarily increase the workload. What you do is you start from the points that I mentioned earlier. You kind of like define what exactly are your areas of threats that you want to focus on, what TTPs you want to focus on, what are the threat actors you want to focus on based on your threat intel program, And then you adopt those detections or those
Only.
elements of your the threat detection ecosystem. You can have a SIEM, EDR, cloud detection, CNAPs, what not solutions are there, and consume those first, right? And
Okay.
then you kind of like process from start off from there. Uh, this allows you to keep the alert volume low, right? And it also allows you to grow and understand what's the kind of patterns that you're trying to see. Uh, then you kind of like evolve from there on, see what's the false positive volume. Are you getting a better ratio between false positive, true positive? And that's how you take your journey ahead from there on.
Okay, okay.
Yeah.
And so another question, which is might be slightly funny, but many times when we go to agile development teams who are doing purely software development, we would ask them to include security as a part of their overall definition of done. Which means, right, at various places you do it, not just security testing after the release happens, but as a part of the user story that they are writing. Now, in this case, are there certain things that you see people miss as a part of their definition of done when they are developing a detection in this fashion?
Uh, False negatives are something that usually come up, but it's a very tricky game, right? Because you don't really it's very difficult to define this unless you test it out in a lab, right? Okay, there are
Hmm.
certain variations that an attacker could do, and a small change in the string or small change in the command line could basically allow the attacker to execute the attack without any log getting generated, right? Or
Yeah.
without any alert getting generated. So it's very tricky, and this is a game that gets keep playing, right? You have to fine tune your detection. It will only detect that one specific element. You have too broad a detection, and effectively you're generating too much of noise. So you have to kind of like bring that into a kind of middle area.
Hmm.
And it's not easy to add that into the definition of done per se, but that comes with experience as to how broad or how narrow your detection logic has to be. Because you don't want to end up messing up too many things, but you also don't want to add up too much of a noise, right? And we'll discuss this further also, but false noise is a very bad element of any threat detection program. And
Mm-hmm.
uh, as we discuss further, we'll come to know like why it's a pain point for most organizations. Uh,
Okay.
so usually this gets end up missing, right? And the other reason is also it's the threats are unknown elements. You don't know what you don't know, right? There's a very famous statement.
Ah,
How do I get the unknown unknown?
unknown
So
unknowns.
yeah, and if I don't know a threat, how do I know that I have to build a detection for it? So people depend on behaviors and algorithms for those kind of detections. But for the known elements, yes, it's good to build a slightly broader detection and kind of like absorb the false positives a bit, but not too broad also.
Yeah, and threats can have, as I understand, a lot of things depending on, in a realistic scenario, when we are trying to find value out of the detection rules that we have written, some of them may never have shown too many false positives, but in a realistic scenario, like for example, when Log4j happened, we were focusing on the software assets that we had and the inventory and the libraries which are vulnerable, this and that, and then we figured, oh, so infra, there is a lot of infra also that we are building on top of also has this issue, right?
Mhm.
So there are layers and layers to this where I think the team needs to be aware of where all it can go, and then some unknowns will always be there in that case.
That's a very good example of Log4j that you brought in, right? Because Log4j was a evolving threat during the first 1 or 2 weeks, right? And
Hmm.
the way it was evolving is that attackers themselves were changing their tactics, right? They went from simple strings, then putting it into the request cookie, then putting it into the
Hmm.
header, and then you had to kind of like capture more there. And
Fuzzing everything.
yes, exactly. Fuzzing each and every parameter in the ecosystem. And then it started also, like you said, not only applications, it hit infrastructure, you could say appliances, firewall, web server thing, and also even in some cases WAF, so VPN devices. It gets very tricky. And that's where this entire process of what we were just discussing, the DevOpsification, helped us a lot. We were able to
Hmm.
move much more faster and deploy this content to customers much more faster because we had that back end system available for us. Make the change, detect it,
Hmm.
get an idea. We had our research team also helping us out over there, identify what new patterns are there, trigger that, and send it back to the customer. So this entire process was much faster rather than me sitting and then configuring it and then testing out. No doubt there were a lot of false positive, but at that point of time, since the heat of the threat was there,
It
customers
wouldn't
were able
matter.
to, yeah, they would rather detect. And there's a very funny issue story also that we have over there. We in this kind of like fast-paced environment, right? we built something that was detecting this large 4J patterns for each traffic, incoming, outgoing, everything. What we didn't realize is web proxy traffic. People were Google searching the patterns in their environment, maybe the SOC team, or people are trying to learn about what the string is there. And those were also getting triggered as false
Getting caught.
positives.
Okay, yeah.
And we had to manually sit and see why are we getting so many false positives over there. And we realized, oh,
Insider threat, not
yeah.
call it insider threat
Yeah.
at the time.
So that was a good learning that, okay, the directionality of the traffic matters in threat detection also a lot, right? Right. We did not think that through a lot because it was like, I remember very specifically we were building those overnight, right? And while for the US folks in my team, it was okay. And the Indian folks, it was like 2 o'clock, 3 o'clock in the night that we are trying to evaluate all of these elements. So it happens, but that's the learning phase. That's the maturity that comes through. And having that backbone set up beforehand allows you to move much faster in these situations, especially when there's an emerging threat. You don't have time to think through on all of these elements at that point of time. Your focus is that if you're under an active attack, you want to be able to detect all those attacks rather than focus more on the false. But there's a counter to that, that if you're inflated with too many false positives, then you lose the real threat, right? So
Yeah.
it's a delicate balance that needs to be adopted.
Yeah, so yeah, that's the time to adapt very quickly. And I remember it was, I think, a time of I think 10 days to 2 weeks within which we had the new version. The new version was affected as well. And then you need to, start detecting that it's no more. So first you say 2.16, I think it was, and then later 2.17 came in. So a lot
The
of things
worst part
changed
it
in
came
those
at,
2 weeks.
yeah, the worst part it came up as was the around the New Year time. So many SOC teams don't have
Ah,
all the full resourcing power. So they are
yes.
kind of like hit from all sides. The threats are changing and evolving. Then you need to have the content developers or detection engineers kind of like adopt to those. The threat intel team has to give you. But when you don't have this entire team with you at that point of time and they're mostly on vacations, it becomes a bit of a challenge.
Yeah, I think that's again where engineering shows you that that you
Yes.
need it way more than you
Right.
think. So while we were talking about it and you were mentioning some of the challenges, I wanted to touch upon a few of them and go slightly deeper and understand what that means. So there is this system that we have set up now, ground up, and we have a bunch of detection rules we've started, and we are building on top of it, just like we do agile development. There is DevOpsification in place, but there are also certain fundamentals that will pose a challenge in terms of actually writing the detection rules for them.
Mhm.
What are some of the mainly challenging aspects for building the program as such? So, in any organization, when they pick it up, the detection engineering generally, anything in security also applies to this, that you may start off with a program, and that program will tell you, bring a structure to, okay, how do we start, where do we start, which we have just discussed. What are the main challenges that you see teams facing at this time?
Certainly. Um, I think these challenges have been in the system for as long as the entire detection industry has been there, right? Unfortunately, it's a challenge that is not easy to solve, and there are multiple reasons for it. The biggest challenge that we have is alert fatigue. I mentioned this earlier also in this session that when you have too many alerts, right, the SOC analyst or the team that's monitoring your detections or alerts, they effectively go in a zone where they are no longer able to process them and say that, okay, either the volume is too high and I cannot hit through all the alerts, or I kind of like desensitize myself to the alerts so that I don't feel that something could be potentially a malicious activity. They simply discard it, saying this is a general activity. And this is something that happens in real life also in terms of our own selves, right? We see it's a not a very good example, but we see an accident happen on the road, people fighting, and then after that, it kind of like gets very normal for us. Okay, this keeps happening. People dash each other's car. There's accidents that happening, and then we simply learn to ignore it. Right? In Mumbai, you have the trains that are overcrowded every time, and then you kind of like get used to it over a period of time.
You don't
So
feel
these
the
things,
pain.
yeah, you stop feeling that shock of these kind of things. When a SOC analyst, if you ask a SOC analyst who's just started his career, right, for him, every small alert is also a major incident. They'll try and investigate deeply, and then that's a good thing, probably. But what happens after a certain point when they get, oh, this is nothing, this keeps coming up every time. And there have been many instances, people have documented their things online also, that sometimes a low alert also ends up being a rare activity While it's low, it would end up being a rare activity, which could have been which ended up being a very high severity activity at the other end, because you might not have a high fidelity detection for every activity. Like we said, we cannot achieve all, right? There are 400 plus sub techniques in MITRE. If I try to achieve all 400 plus, I will have the counter effect. I will have too many alerts now.
Yeah.
So this alert fatigue is again another delicate balance that we need to handle. Every new detection that I build in the system, right? And I want to be building as many detection as possible, because if you look at it, detection at its core has one goal: build reliable detections without adding too much false positives and too much of alerts. But these are opposing goals. You add one new detection, you will get 10 false positives, you will get 20 alerts, right? So these are opposing goals in its own nature. The beauty of this is that as you mature and as your SOC, your detection engine program matures, you will be able to reduce that gap to much lower level. And you cannot eliminate it, because that's the point, right? You don't want to eliminate it, because if I try to bring false positive to zeros, I will be increasing my false negatives also, right? I don't want to be doing that. I need to have some appetite to absorb those false positives. And that's where SOC teams and threat detection teams need to understand that false positives are fine. There are some organizations who wrongly focus on eliminating false positives. That should not be the goal. Your goal should be that you reduce the false positives, you reduce the alert fatigue levels, so that your SOC can easily process those alerts without getting too much bogged down into unnecessary alerts in the system. And that's a continuous problem that gets solved, right? The SOC analyst has to be able to give a feedback. Actually, by the way, this is not only specific to detection engineering teams. This is a full SOC, or you could say loop. The monitoring team has to give a feedback to the detection engine team. The detection engine team has to get feedback from the threat intel that, okay, these things have changed. The TTPs have changed. Now you need to modify your approach. The detection engine team themselves have to have some mechanism to track these elements, right? So there has to be some level of investment that organizations have to make. It's not an easy investment, because the ROI over here is difficult to translate. You are putting time and effort to monitor and redo the same activity that you've already built. So usually how KPIs are built is that I see progressively I'm adding more rules into my system. I see progressively that I've detected more threats. But what is not usually captured is like, what's the alert fatigue levels? What's the kind of like volume of alerts that I've generated, and how am I reducing them? Mature organizations, they realize this problem early on, and they kind of like say that, no, I want to be able to bring down the levels of false positive in my environment. And they then try to put this into part of their program, that there is a cyclic process. You monitor your older alerts or the older detections, bring them down periodically and fine tune them. This fine tuning concept, it is done mostly as an alert suppression mechanism rather than tuning the detection to be able to increase your false positives and reduce your false negatives, and also reduce your increase your true positives, reduce your false negatives, and also reduce your false positives. Right?
Positives.
But too many false and true words from here. But
I think,
yes,
yeah, we'll have to add that in the description for the
yes,
listeners to
because
follow.
see, it's very difficult for any vendor to give you default rules which will be adopted to your ecosystem, to your
Completely, yeah.
environment. Right?
Yeah.
Every organization that we have seen work with is different. Right? One rule which has triggered, which is very high fidelity in one customer, we have seen that same rule be very noisy in another customer.
In another one. Because the
Right?
context would also change, right? The
Yes,
environment, the tech stacks, a lot of things will, domain will
exactly.
change. So attacks will, may not apply
Correct.
in those
Yes.
cases.
Right. Plus, over there, then you start introducing algorithmic based detections, behaviors, UEBA, AIML, all of those stuffs. And those over a period of time, they get tuned out on its own, or they're expected to get tuned out. But again, they will have some level of buffer or threshold within themselves, within the algorithm definition, to allow that false positive to come through. Plus, since they're based on behaviors, human behavior changes, right?
Yeah, yeah.
You cannot keep expecting that, okay, one person who logs in at around 9 o'clock every day will keep logging into that. That shift changes, the detection goes for a toss, right? Any such small
Yeah.
change in the ecosystem can break the detection for you, right? So you should be prepared for that, and you should know that these affects the alert volumes, and we have to have a continuous process. You cannot just say that I build a detection, after 1 year I'll come back to this, or maybe I'll never come back to this. That doesn't happen. Lastly, a detection could have served its value and it's no longer required, right? You need to be able to remove that out from your system so that you don't increase the alert volumes, you don't increase the operational maintenance overhead for all of these new detections that you've created. So, like I said at the start of the discussion, right, there's a life cycle that gets created with this detection engineering function. You start with one and then you kind of like bring that entire detection to a sunset if it is no longer relevant to your organization. But the key point is the relevancy is to your organization, right?
Yeah, yeah.
There might be organizations that are using Windows very old versions, maybe something which is in a very prominent in OT ecosystems. Maybe they're using
Yes.
XP, right? They're
As
using XP over
always,
there, and they have something with the at command attacks. Now, today, if you ask me, that detection has no value everywhere across. But then for that specific organization, yes, they still
it
have
has.
it has value, right? So they might want to retain it, but I cannot go and tell all my other customers that you also need to retain this. It's just unnecessary cost and cycles and CPU processing. So we kind of like deprecate those, we remove them from the system, and that for that one specific customer, we tell them, okay, you maintain it because it's required for your environment. Again, this judgment comes from the organization. The threat perception, your risks that are there for your organization, your threat intel program tells you all of these. So it's something like all of these teams have to talk to each other. If they don't, you increase the inefficiency in your teams.
Yeah, I think in some of the previous episodes as well, I think we touched upon the importance of this internal collaboration itself and having the feedback being shared. Is there a way to that we automate this efficiently so that because while we might automate a lot of things through detection engineering itself, that is when we start writing detection rules and maybe once the rules are written, it keeps on applying in throughout the life cycle. But once you continuously keep getting the feedbacks, the state of that detection might change, like you are rightly calling out. Is it automated as well? Because if this part is manual, the rest of it is manual, then if it will impact the cycle of how valuable this detection was.
So it's difficult to automate a feedback loop completely. There are parts of it that you can certainly automate, right? You cannot, at least I'm not aware of teams that have done this completely, fully automated as a process. But what I've seen is that you have a feedback loop from the monitoring team, from the threat intel team, and there is some collaboration that happens in the middle where you say that, okay, this is the monitoring team is in touch with the customer usually, right? So they tell, okay, this detection has gone for a toss, but it was because of some activity that happened. So if there is a feature in the platform to temporarily suppress certain alerts, the detection in team can go ahead and do that activity over there. So that helps reduce the alert volumes. If the business, or we could say the organization, tells the SOC team that, okay, we are going to be running some downtime or DR drills, right? So don't trigger alerts for these assets in your environment. That allows you to keep your SOC team sane, right? Otherwise, they'll say, "Oh my God, the entire IT infrastructure is down. Somebody has attacked us. We are under attack." So it creates a chaos. So proactive communication helps. Um, Usually, we have seen that stakeholder leaders, they usually get up in a sync on at least the business owners and these SOC heads. They usually come into sync and say that, okay, we are monitoring these assets, any activity being planned over here, anything that we should be aware of, anything that's changing in the environment. Businesses are not static, but they're not bothered about all of these other elements that are on overhead to their functions.
Yeah.
So it has to be a proactive activity from the cybersecurity side of things. And if you look at it, it's not unique to threat detection, right? This happens, like you said, other guests have also mentioned. It is something with assurance, or you could say AppSec. It is something that we have with network security. It is something that we have with patch management. Everywhere, cybersecurity functions have to proactively reach out to the business functions and ask them, okay, what's the new update that is happening and what's changing in your environment? How can we help you? Right? That effect where we are trying to effectively secure them or save them provides the assurance to the business function that we are not being an impediment to their growth. End of the day, if we are the cost center, they are helping pay our salaries, right? And we should be aware that we have to keep them happy, that they don't lose business, and effectively we don't have an impact.
That was a secret I wasn't talking about, but you said it anyway.
Yes.
But yeah, I think it's just I was looking at more on the technical activities, like you called it activities, right? So there's a standard set of activities which can be turned on or off, or at least can be enabled with respect to certain threats at certain times, because we know that that may happen for a certain domain, which applies to us as a team. So but I think that itself will also take some intelligence eventually to be built into that, so that systems can themselves then look at alerts which are not applicable and may help bring down false positives further, because immediate feedbacks are received in a very standardized fashion, and then that can be
Correct. Yeah. So there are
logically
ways
worked
where
out.
SOC analysts can always, when they're processing that alert from the into the incident, right? They always provide them feedbacks to that incident. Was it a positive? Was it a false? So that is one of the elements of feedback loop that goes back to the engineering team, right? And they said, okay,
Okay.
this one alert has triggered too many false positives, and the kind of like pattern is derived from those alerts. Okay, maybe I need to exclude this string from my detection going forward so that it avoids or reduces the false positive. The other piece is that you need to be able to monitor trends in your alerts or the rules that you have over one at the individual policy level or use case level. The other is also at the higher level, right? If the alert volume is significantly increased, then you know there's a problem. Or if it's significantly decreased, then that also indicates a problem. What we always say is that what if the alert is exploding? Yes, that is a problem. But if your alerts have gone silent, that's another problem you need to look at, because that could be indicative of maybe the change in data sources, or maybe the data sources stopped logging because of some misconfiguration that happened, or a restart that happened that did not complete properly, or there's a data drift. So this absence of logs or absence of alerting or reduction in alerting is also another cue for the detection team that something has gone bad, right? It helps to kind of like create that feedback loop from the system, like in some manner that you said automated. The monitoring part can be automated, certainly. The feedback loop from the SOC monitoring team can also be in some form of fact, you could say the loop feedback can be automated, but then end of the day, the team has to process it out, right? So it's still, I would say, a work in progress overall. It's not an easy problem to solve, because then you're effectively saying that 20 people in the SOC have to talk to those 5 people engineers who are there and provide them the feedback. So there is a translation gap that can happen. It
Yeah.
will be a journey that any organization has to take, right?
Right, right. So since you're talking about data sources just now, and this we have discussed a couple of times earlier also in the podcast, and everybody has a different view. I'm sure in the journey for every team where they are starting to add different data sources, I'm talking about logs, and log ingestion is also something that you mentioned earlier. There is a different variety of systems that will keep giving you log inputs, right? The systems take it, and detection works on a lot of these logs, basically. What do you have to say in terms of the challenges there? Because there's a huge variety of logs that can be there. Like where do we go about when we are setting
Yeah,
up the
this
detection engineering in this case?
and despite the industry being quite an old in right now, I think the threat detection has matured a lot. Like SIM came up in somewhere around 2000s and all. We still haven't figured out a standardized mechanism of logging, right? There have been different initiatives, right? Different vendors have tried to kind of like bring collaboration in that. But every product that comes up, right? Every technology that gets built, they create their own format of logs. I wouldn't blame them, obviously, because as they have evolved, they've identified new things to add into their alerts. But the structure, the format, and the way they track severity, all of that keeps changing from product to product. And this becomes a very big pain point in terms of any function that wants to monitor these technology elements. They need to first understand the log formats. They need to understand what are the log events that are getting generated and how do I normalize it? Because without normalization, what essentially happens is you have to build detections individually for each data source. Again, that goes back to the first issue. You need scalability in your detection engineering program. If you don't have scalability, an enterprise, which is maybe a very large bank or something you can have, it will have many technology elements. And each of those products, it could be cybersecurity technology, it could be IT infrastructure. Each of them will have their own way of monitoring stuff. And if you
Yeah.
don't normalize it, you will lose out on correlation, you will lose out on context. Not everyone in the team will have the same understanding of every log. So normalization becomes important. But unfortunately, normalization itself is very complicated because of these other source issues that I just mentioned. Every product creates their own formats, and there is a cost associated with being able to parse out and read all of these logs after you have ingested them into your platform or after you have processed them, right? So log standardization variety also matters a lot. The other problem we have seen and is a big pain point, I would say, with these security products and vendors is not every vendor gives equal amount of logs, or they don't give similar kind of logs, right? Look at the cloud ecosystem itself. You have three major players. I wouldn't take names over
Hmm.
here, but they don't
We
necessarily
know.
give similar types of logs every time, right?
Hmm.
Some are overlapping, yes, but there's a very weird thing one vendor does. They slice out their logs based on the license or the subscription that you have. So you might get 5 out of 10 events if you are on
Hmm.
subscription level one, but if you are subscribed to their top level, then you will get all the 10 event times. And this
Hmm.
hampers any function because then you don't know one is what has been subscribed over there. Maybe there are some accounts on that cloud platform which have a level one. There are some accounts which have level two, level three. That subscription level changes and your logs also change at the other side, right? So it depends on how you've integrated those logs into your environment. You will not be able to have a consistent detection logic or detection mechanism. There would be gaps that get created because you don't have the logs then. You would have
Hmm.
assumed that, oh, I saw these logs come into my environment, but then what you don't realize is maybe your one user has those logs, the other user doesn't have because your subscription has changed now, right, for your accounts. So these kind of changes in the logs become a very big headache for any SOC team, any detection team, because we have a major dependency on the data. Without the
Hmm.
data, we are nothing, right? I can run as many analytics as I want, but if my data is not processed correctly, my parsing is bad, if my normalization is bad, my analytics, my rules will not run,
That's the
right?
starting point. Yeah.
Exactly. And this is very well put into a very small phrase by Anton Chuvakin. He's a veteran in
Hmm.
threat detection and SOC and SIM technology. He said that if you have garbage in, you will get garbage out. What it basically means is that you put garbage data into your SIM platform or threat
Yeah.
detection platform, that means logs, and you will get garbage detections out because then you will have bad alerts, bad saying false positives, and those even the
Hmm.
alerts that get detected don't have much context and all that stuff. So the data is a foundation element, and with bad data, you will not be able to process much. Even after you get the alerts, and if your data is not well structured or not well parsed out, you will not be able to process the alert correctly because then you
Hmm.
maybe need something that you want to pivot the data on, right? You want to hunt further and investigate that incident further. Your data is not good, you will not be able to process it. So data becomes another important point that any organization has to focus on. If your data is good, your program can mature. If your data is bad, then you'll be stuck in the same rut forever.
Like you can write great logic with your detection, but as long as you're not able to even detect what's happening
Yeah.
with the
In a
logs
lab,
and
it
where
might
it's
work
going.
fantastically. Yeah. In a
Yeah.
lab, it can work great because then I have a control environment. But
Yeah.
the real
Yeah.
world, once it hits, it is different, right? False positive is another element, but the real world, the logs, we have a concept called as data drift. The data
Hmm.
can change a bit, right? Maybe we are not aware. The product has gone from version one to version two itself. And very recently, we had an example where the vendor itself had updated their APIs from one version to another. The data, the log, what information it used to send, how they used to process the information at the end, that changed completely, right? So the EPS count for that data source also changed. It went from a few thousand EPS to a few hundred EPS. And then we are wondering, oh, yeah, what exactly happened? Or even, but over there, the customer changes the data source. We are not aware and it changes the entire log data. It changes the alert patterns. It changes everything in the downstream elements. Why? Because something changed at the start of the data.
Yeah.
So this,
Yeah.
this this again goes back to the collaboration element. If you have a strong collaboration between your business, your IT, your SOC, your detection teams, your program teams, then it becomes a happy family. Otherwise, if there are no collaboration initiatives between this, you don't talk to each other, your program will fail.
Yeah, and we have, and I'm just wondering that we have not even yet started talking about intelligence and other things which are, these days we are talking a lot about in various areas, in various technologies, security technologies that we have. And there are already so many areas to discover and complexities when it comes to detection
Yes.
and inculcating all of that in detection engineering.
Right.
Cool, but thanks a lot for answering so many of these questions. I think I would like to have more episodes on this. If because detection engineering I see as an area that is yet to mature further, and like you're talking about, not just industry collaboration, but enterprise collaboration and different kind of inputs that we can keep getting, different kind of feedbacks that can be automated, and all of different possibilities which are there with detection. So would
Mhm.
like to explore that further in the next episodes that we may have together. But thanks a lot for
Thanks
answering
for
all the
having me.
questions
Yeah.
today, Wasim.
Thanks for having me on this. Really enjoyed this conversation, right? And the last point that you just mentioned, it triggered a response on that in the three of you, right? When you mentioned industry collaboration, right? And detection engineering is still early stages. Why? In the sense that if you look at Intel, threat Intel, there's a lot of cross-industry collaboration,
Collaboration.
cross-vendor collaboration, cross-organization collaboration. But that same thing doesn't happen with the detections, right? You kind of like, there is some sort of a thought process that, okay, our detections need to be secure and safe with us. That essentially hampers organization, because when you're not sharing your detection effectively, you are not sharing your knowledge about how these threat actors have to be detected. Threat actors are publishing open source tools. Detections are not shared very openly, right? They have their own reasons, right? It's considered differently by different organizations. But that collaboration that you mentioned, threat intel, IPs are shared left, right, and center. While they have
Yeah, exactly.
short shelf life, but even the TTPs, the threat reports, there are a lot of things being shared a lot online in the community. Uh, Detection engineering is getting there. It is evolving. There are a lot of people talking about it now. Organizations have to start talking about it a lot so that there is vendor collaboration, there is peer organization collaboration. There are no platforms for these kind of things right now. It's mostly about threat intel sharing, which is great because it's a foundation of even threat detection engineering, right?
Right.
So it's great to have that. But then hopefully sometime in the near future, maybe when we have our second discussion or so, the industry would mature by then, or we would have some more new updates in the industry, like how this collaboration can get affected, right? But it
Yeah,
was great
hopefully.
chatting with you. It was great chatting. Thanks a lot for having me on this podcast, and great discussion. Thank you.
Yeah, thanks for being here, Wasim. And looking forward to another few episodes with you on in the area of detection engineering and
Certainly.
others.
Look forward to it.
Cool. Thanks everyone for joining us today. We'll see you in the next episode. Bye bye. Hey y'all, if you enjoyed this episode, don't forget to like, share, and subscribe to Breakpoint Security Podcast. Your support means that we can bring more such conversations back to you. Share with your friends and colleagues, and stay tuned for more episodes from Breakpoint. Until then, bye bye.